Hey everyone, once again I'm back. I'm Erisa to take you through online lectures. We have been talking about integral calculus, and this is going to be our 13th lesson in integration. We want to talk about the integrals of trig functions involving the t formula. We talked about this last time, and we saw a particular form of integrals. Today, we want to talk about the integrals of the form over a plus b sine x plus c cos of x by dx. Okay, and we shall not really waste a lot of time. The key here, is to substitute, okay, t equals to tan x over 2. Okay, last time we saw the one having squares. It was a plus b sine squared plus c cos squared. We're using t is equal to tan x, but with a plus b sine x plus c cos x, we use t equals to tan x over 2. Now, if you have an angle, okay, let's go to the right angle triangle, because these trig ratios, sine, cosine, and tangent, are defined for right angle triangles. So we want to see, okay, if we have a situation where this angle is x over 2, and we are saying that the tangent of x over 2 is equal to t. Of course, every number stands over 1. We know that for a right angled triangle, tangent is opposite over adjacent. So the hypotenuse using Pythagoras theorem is the square root of 1 plus t squared. So we can read off sine x over 2 and cos x over 2. This will be very simple. Okay, so what will be sine of x over 2? We know sine is opposite over hypotenuse, so this is t over the square root of 1 plus t squared. Okay, and then the cosine of x over 2 is equal to, okay, adjacent, which is 1 over the square root of 1 plus t squared. We also know that the sine of x can be interpreted as sine x over 2 plus x over 2, okay? And by the double angle formula, this gives us 2 sine x over 2, then cosine x over 2. And if you substitute the expressions for sine x over 2 and the cos x over 2, you end up with 2t over 1 plus t squared. Okay, the same happens to cosine x as the same thing as the cosine of x over 2, okay, plus x over 2. And you know the double angle formula for cosine is cos squared x over 2 minus sine squared x out of 2. So this would be 1 minus t squared over 1 plus t squared. So we can always make use of these substitutions. Remember, this integral is with respect to x, okay? We have to also change the variable from x to t. How do we do that? Let's get that in a second. Since we are making the substitution, t equals to tan x over 2, we can start dt by dx, okay, is equal to, when you differentiate tan, you get sec, but you have to differentiate the angle and multiply, so this is a half sec squared x out of 2. So I can, this dt by dx, okay, this is dt by dx. So I can say that dx, okay, If you cross multiply to be 2 dt, then you divide by sec squared dx. Okay. Now, sec is the same as 1 plus tan squared. Okay. This is the same thing as 2 dt out of 1 plus tan squared x out of 2. Okay. So, what is the tangent? Tan x over 2, we have defined it as, okay, we have defined tan x over 2 as a t. Okay, so if it is tan squared, then this is 2 dt out of 1 plus t squared. So we can now go ahead and integrate. Okay, remember we have the integral is 1 over a plus b sine x plus c cos x by dx. So what we are left with is to substitute for dx is equal to 2 dt over 1 plus t squared d. We substitute for sine x as 2t out of 1 plus t squared d, and then the cosine of x is 1 minus t squared d out of 1 plus t squared. So those three substitutions will help us solve integrals of this form. Okay, so why don't we look at an example? All right, let's look at this example. They want us to integrate, to evaluate, to find the value of this integral. Okay, and when you look at it critically, it is of the form, okay, is of the type. What type? Integral 1 over a plus b sine x plus c cosine of x by dx. It is only that here the value of b is 0, so b sine disappears and we have only a and c cosine. Okay, so we make use of the substitution. Okay, let t equals to tan x over 2. So as a student, you are supposed to go back through, the procedure of getting sine x over sine x and cosine x, the way I have done using a right angled triangle. But because I want to save time, I have tried to show you how that is done. I will not repeat myself, but if you are having this question in an examination or you are trying to answer or discuss for someone, you have to go all the way through the right angled triangle, how we get sine x over 2, how we get cos x over 2, and from that how we get sine and cosine, and how we change the variables from dx to dt. Okay, so I will make a substitution, but since the integral has limits, let me go ahead and change these limits to in terms of t. So I have x, and then I have t equals to tan x over 2. Okay. So if that's the case, you have x and t is equal to tan x over 2. Then you go ahead and change these limits. Okay. The first x limit is 0. Okay. And the tangent is the same thing as sine of 0, which is 0. Then the second is a half of pi. So here we have t is equal to tan half of pi over 2. That will be tan pi over 4, which is 1. The tangent of 45 degrees is equal to 1. Remember, when we are integrating, okay, or differentiating, that's the calculus, we deal with radians. You will not find this written as 0 to 90 degrees, no, because when we are integrating, we integrate radians. So we are always dealing with the pi. You are using pi as, the angle in integration, not degrees, okay, because we are dealing with radian. Then hope I'm clear on that. Now we have changed the limits. Okay, why don't we go ahead and integrate? Integral from 0 to a half pi, okay, dx out of 3 plus 5 cos x will be the same thing as integrating from 0 to 1. Okay, what are we integrating? We're integrating 2 dt over 1 plus t squared divided by 3 plus 5 into 1 minus t squared over 1 plus t squared. So as a student, you go ahead and do your mathematics, okay? So this will be equal to the integral from 0 to 1, okay? We are having 2 by dt over, that is 3, okay? Plus 3t squared minus plus 5, which is 8, plus, okay, this is gonna be, okay, 3t squared and then minus 5t, so it is 8, okay, minus, this is minus 2t squared, okay, 8 minus 2t squared, and this will be the integral from 0 to 1. It is a dt out, but 1 over 4 minus t squared, the same thing as 1 over 2 minus t into 2 plus t, okay, which by partial fraction is a over 2 minus t plus a b out of 2 plus t, okay. So you can write 1 is equivalent to a over 2 plus t plus a b out of 2 minus t, okay. So what happens is when t equals to 2, this will cancel out and we have a is equal to 1 over 4, okay. What if, okay, t is equal to negative 2, okay, we shall have b is also 1 over 4. So a equals to 1 over 4 equals to b. A and b, they are the same. So we can now go ahead and split this and write the integral. Then after, we have the final answer. Okay, the integral from 0 to a half pi, okay, which is now dx out of 3 plus 5 cos x, okay, is now going to cos of x is now equal to the integral from 0 to a half pi of, okay, we have 1 over 4 into 2 minus t, okay, plus 1 over 4 into 2 plus t, and you're integrating this with respect to dt, okay. So this is no longer pi, it's a 1. We change the limits, remember. So what do we get? We get 1 over 4 natural logarithm of 2 minus t, okay, that is a negative, plus 1 over 4 natural logarithm of 2 plus t, okay. Remember when we are integrating, okay, there are those integrals that involves natural logarithms. You differentiate somewhere in the denominator. That's why this is a negative, okay. So if you arrange, use laws of logarithm, this is going to be 1 over 4, okay. They have natural logarithm of 2 plus t out of 2 minus t. So let's now feed in the limits, 0 to 1, okay. When you substitute the upper limit, that's t is equal to 1, that will be natural logarithm of 3, isn't it? So we have this as equal to 1 over 4 natural logarithm of 3 minus natural logarithm of 1. But natural logarithm of 1 is equal to 0, so the final answer is a quarter, okay, natural logarithm of 3. And the integral is done. Look at this example 2. They want us to integrate sec x. We begin by defining what sec is. It's the same thing as integrating 1 over cosine of x by dx, okay. Using the t formula, let t equals to tan x over 2. In the same way, you have to show that cos x is 1 minus t squared out of 1 plus t squared. And you also have to show that dx will be twice dt over 1 plus t squared. So the integral of 1 over cos x by dx becomes the integral of 1 over 1 minus t squared out of 1 plus t squared, then times 2 dt over 1 plus t squared. And if you go ahead and do your mathematics, this is going to be the integral of 2 dt out of 1 minus t squared. So this will take us to partial fractions, okay? You can look at that. But 1 over 1 minus t squared is the same thing as 1 over 1 minus t into 1 plus t, okay? So this will be, in partial fraction, it will be a over 1 minus t plus b over 1 plus t. As a student, you have to show that a equals to a half equals to b. As a student, I'm leaving that for you. You will be able to show that by resolving into partial fractions. Okay, so what does it mean? Also, there are no limits here, so it's not a big deal. It means that, okay, the integral of sec x by dx is now changing to the integral, okay, of, let me write this, 1 over, okay, 2 into 1 minus t plus 1 over 2 into 1 plus t, then times, okay, twice dt. So let me put here 2 dt. It's supposed to be 2 dt, but I pulled out a 2. So this is gonna be, okay, and the integral of 1 over 1 minus t plus 1 over 1 plus a t, all right, by dt. So what do we end up with? Minus natural logarithm of 1 minus t plus the natural logarithm of 1 plus a t, okay, and this is the same thing as the natural logarithm of 1 plus t over 1 minus t, okay? So we can write that therefore the integral of a sec x by dx takes us to natural logarithm of, this is 1 plus tan x over 2 over 1 minus tan x over 2, and then we are done, okay? Natural logarithm of tan x over 2 is over 2, and we are done. That's the integral of a sec. So just something like that. Ladies and gentlemen, we have had 13 lessons in integral calculus. We shall be talking about the applications of integration, areas under curves, volumes of revolution, solids of revolution. That will come later on. But coming up, we're going to talk about the circles, locus, then conic section. And I'm also going to start talking about paper 2. I'll begin with probability, then we got discrete and continuous random variables, normal distribution, okay, normal approximation to the binomial distribution. You know, but a binomial distribution is a special type of a discrete random variable. So that's coming up, okay. And ladies and gentlemen, if you have any comment or you want to be helped in something, feel free to send me an email. I've included my email. Feel free to write me an email. I'll respond to you. Thank you so much. Ensure you share this information with your friends, and don't forget to subscribe. Remember, this part of the first part of integration, where we have had 13 lessons, I'm gonna create a playlist where all the topics I've done will be listed in order. So I'll be sending you the link of the playlists very soon. Thank you so much, ladies and gentlemen. Have a nice day.